Welcome back to our course, Network Theory and Transmission Lines. In today's lecture, we will start the Unit 3, that is the two-port networks. So where in the two-port networks, we are going to discuss about the different two-port network parameters. So in this lecture, we are going to discuss I'm going to give some introduction about the two-port networks. So these are the outcomes of our presentation, that is today's presentation. That is, we are going to learn about the definition of a port. And by the end of this lecture, you are going to know the definition of a one port, and you are able to differentiate the one port and the two port network. And you are going to know about the uses of the two port networks. That means the necessity of a two port network. And what are the different types of network parameters? How you are going to represent it in a equation form. So coming to the two port networks, generally, if you look into any kind of network can be represented using a rectangular box. So that means here a network can be used either for a purpose of the source or it can be used to represent a load. Or it may have the many other purposes also. But here, if you look into the two-port network, we are going to know about what do you mean by a port. What do you mean by a port? A port is nothing but here a port is going to have the two terminals. That means a pair of terminals through which we are going to have the current. Through one terminal the current may enter and the other terminal the current may leave the network. So here in this part you can see this is nothing but a single port. So that's why it is nothing but a one port network. So here a pair of terminals at which the signal may enter or leave a network is called a port. So that means a port is defined as any pair of terminals. A port is defined as any pair of terminals through which the energy or the current is supplied and the current or the energy is withdrawn from the other terminal. That means the energy is supplied through one terminal and the energy is withdrawn from the other terminal. Right? That means here in terms of current, the current may enter through one terminal or it may leave the other terminal. So till now we have discussed about many two-terminal devices or elements such as the resistors, capacitors, inductors. These are all the one-port networks because each and every element is going to have the two terminals. One is going to represent the highest potential, another one is the lowest potential. So this is nothing but a two-terminal network or a single-port network. Right? So where here a two-port network, if you want to define a two-port network in terms of electrical quantities, it is nothing but is going to have a two ports. So one port can be used for the input and the other port can be used for the output. So this is clearly illustrated in this figure. If you consider any kind of a linear network, that means linear network in the sense where the output is linearly dependent upon the input. So that means here the two-port network is going to have a two ports. You can see this is one port and this is the other port. So it is going to have two pair of terminals. So one pair of terminals is going to accessed by the input and the other pair of terminals is going to accessed by the output. So in the two-port network, the current entering one terminal of a pair is going to leave the other terminal in the pair. The same concept applied here also. But here, whereas here in the two-port network, one pair of terminals is corresponding to the input side and the other pair of terminals is corresponding to the output side. So these kind of building blocks or these kind of networks is very, very common in the electronic systems. Like if we consider a communication systems, transmission and distribution networks, the many transmission systems, this kind of networks is going to be same, very, very popular in this, right? So whereas coming to the structure of this two-port network, so we are going to have the V1, we are going to represent the V1 or the input terminal Vi. If we consider in some textbook, they may note it using Vi. This is nothing but our input voltage V1, and V2 is going to be our output voltage, and I1 is going to be our input current, and I2 is going to be the output current. So usually we will represent both the currents is going to entering towards the network. In the two-port network, this is the two-port network convention. In the two-port network convention, usually in general, we will consider both the currents. I1 is going towards the network and I2 is also towards the network. So here I1 is entering through this terminal, that means the top terminal of the left side, that means the left side port, and it is going to leave through the down terminal of the left side port. Whereas I2 is going to enter through the right side port, that is the output side port and the top terminal, and it is going to leave through the down terminal. So this is what the general convention of a two-port network. So in this, we can observe that we are having four terminals. One is for the input side port, two terminals, and the output side port, we are having two terminals. So similarly, we are going to have four variables. One is the V1, V2, I1, and I2. In a two-port network, we are going to have the four variables. So this is clearly mentioned here. We are going to have the four variables: V1, V2, I1, and I2. So when we are getting different types of equations or different types of parameters, so based upon these terminals or based upon these four variables only, we are going to classify this. So how we are going to classify? So generally we will choose two variables. Either it can be V1, V2, or it can be I1, I2, or it can be a V1, I1, or it can be a V2, I2. It can be of anything. We will choose two variables as the independent and the another two variables as the dependent variables. So taking two at a time, two variables at a time, we may get from four variables, we may get around six possible combinations or six possible combinations. Through that six possible combinations, we may get around six possible pairs of equations. These equations is going to represent, you have to remember this point, these equations is going to represent the dependent variables in terms of independent variables. Dependent variables in terms of independent variables. We are going to represent, the equations is going to represent the dependent variables in terms of independent variables. The coefficients of these independent variables is going to represent your parameters, two-port network parameters. We are going to represent the two-port network parameters. So each pair of equations is going to have a four set of parameters. So what are those parameters? How we are going to classify those parameters? Repeat again, here we are going to classify the network parameters based upon these combinations of four variables. These four variables is going to group either as a independent and the other two variables as a dependent. So considering the two variables at a time, we may get from four variables, we may get around six possible combinations. So 6 possible combinations is going to lead to the 6 different parameters. So what are the 6 different parameters? So the parameters of a two-port network, these 6 parameters of the two-port networks are known as the two-port network parameters, or you will simply known as the two-port parameters. So the two-port parameters are the Z parameters, Y parameters, ABCD parameters, inverse ABCD parameters, H parameters, and G parameters. These are the conventions of the two-port network parameters. So the Z parameter, Z is nothing but the impedance, right? And Y is nothing but the admittance. This ABCD parameters is nothing but the transmission parameters. Transmission parameters. This inverse ABCD parameters are also known as the inverse transmission parameters. Hybrid parameters, H parameters in the sense hybrid parameters. G parameters means inverse hybrid. We will say it is inverse hybrid. What is the inverse hybrid? G parameters. Transconductance parameters. Based upon this transconductance parameters, G parameters. Right? So Z parameters are also nothing but the open circuit impedance parameters. Y parameters are also known as the short circuit admittance parameters. ABCD parameters are known as the transmission parameters. This is inverse ABCD is known as the inverse transmission parameters. H parameters, hybrid parameters, G parameters. So these are the 6 possible or 6 different types of two-port network parameters we can come across using the combinations of independent variables and the dependent variables. What are those independent? It can be of any one of those V1, I1, V2, I2. And the dependent variables, 2 variables can be of any one of those, that is V1, I1 and V2, I2. So these are the different parameters. Z parameters, Y parameters, ABCD, inverse ABCD, H and G. So coming to these parameters, if you look into these parameters in brief, so these are nothing but we are going to discuss about this impedance parameters, admittance parameters, transmission parameters, hybrid parameters, inverse hybrid parameters, everything in detail. So these are the different parameters. So that means here V1 impedance parameters are represented using the equations V1 and V2. That means V1 and V2 are nothing but your dependent variables. So whereas here also admittance parameters I1 and I2 are nothing but the dependent variables. In the impedance parameters V1 and V2 are nothing but dependent variables and I1 and I2 are nothing but independent variables. And admittance parameters I1 and I2 is going to be our dependent variables, V1 and V2 is going to be our independent variables. And similarly in the transmission parameters or the ABCD parameters, this here V1 and I1 is going to be our dependent variables, V2 and I2 is going to be our independent variables. And in the hybrid parameters, if you look into this, V1 and I2 is going to be our dependent variables and I1 and V2 is going to be our independent variables. Right. So this is going to be our G parameters. Inverse, this is known by inverse transmission parameters. V2 and I2 is going to be our dependent and V1 and I1 is going to be our independent. Whereas here G parameters, I1 and V2 is going to be our dependent variables and V1 and I2 is going to be our independent variables. So now the coefficients of these independent variables, that is for the Z parameter, the coefficients Z11, Z12 and Z21, Z22 is going to be our Z parameters. And Y11, the coefficients of the independent variables in this, the Y11, Y12, Y21, Y22 is going to be our coefficients are nothing but your admittance or Y parameters. And this here for the transmission parameters, what are the coefficients for the independent variables? A minus B, C minus D, or we can say A, B, C, D is going to be our transmission parameters. Transmission parameters. Whereas here, hybrid, coming to the hybrid here, H11, H12, H21 and H22 is going to be our coefficients of these independent variables are nothing but H11, H12, H21 and H22. This is going to be our hybrid parameters. And coming to the G parameters, the coefficient of the independent variables are G11, G12, G21 and G22. So these are nothing but your G parameters. These are nothing but your G parameters. Now we will look into each and every individual parameter in detail, how we came across these equations, how we are going to solve the parameters of the impedance parameters, how is going to get these equations for values for Y11 or Z11 or Z21. We are going to solve these equations in each and every individual. Right. So this is going to be our introduction class. Thank you. In the next lecture, we will look into each and every parameters in individually.